Hey guys, welcome to another video of Mr. Little. In this video, I'm going to show you one model that I've made, very simple model, that is linear regression model. So here I have an X data, and here I have a Y data. Let's keep it simple, so just 3, 5, 6, 7, 9. Yeah. Now what we're gonna do is we're gonna set up the model. Here we go. It's done. Now we are gonna do model dot fit. We're gonna put the X and Y. Then we're gonna do some prediction. A model dot predict. Let's give it number 100. So if we just print A, it must return 1 from this data. We can see if we do it, there's only 101. Yeah, so yeah, it's correct. Let's just make some small changes now. If we do it like 10, 20, 25, 30, 40. Now you can see I just multiplied this by 5, so this must be 500, and it is, so it works fine. So this is a linear model. Now let's see how we have made this. Okay, first of all, we initialized it. A linear model attributes m, float, c using the basic formula for linear equation, that is your y equals to mx plus c. Now we have done the self.m equals 0, self.c equals to intercept. Here the m is slope and the c is the intercept. Here's the def fit, the fit function. Here I have put an example usage. Now here, for finding out the m, we are using the formula n into sigma xy minus sigma x into sigma y divided by n into sigma x square minus sigma x whole square. Now what does it mean? This means the sum of x and y, x into y, sum of x into y, sum of all x's, sum of all y. Here sum of all x square, sum of all x, and then we're just squaring it. N equals to ln x. So here our x can be like 1, 2, 3. So what will it do? Our n will be 3 here. Okay. Now next xy sum, that is our sigma xy function here. So we did a sum of every x into y. So suppose it is 1, 2, 3, and then our y is like 4. So we're just gonna do 1 into 4, 4 plus 2 into 4 dot dot dot. Okay. xi into yi for xi and yi in zip xy. Actually it won't do it, I guess. Okay, whatever. Now the sum of x, that's sigma x, the sigmoid, I guess that's what it's called. Then y sum of y's, this one. Then we just did the x squared sum. What's this? Okay, this is the xi to the power 2, this to the power 2. Wait a minute. Oh yeah, this one. X to the power 2, sum of x square for all x side. Okay, suppose we have 1, 2 and 3, so it will do the sum of 1, 4 and 9. It will be 14. Okay, so this becomes 14. It is being used here. Then n, that is your length of x, that is 3 into 14 into x sum. What will be the x sum? Wait, let me just keep it here. Okay, sum of x will be 6 to the power 2 for this sigma x whole square. Then this is our self.m, that is this slope, and then the self.c, that is your intercept, sigma y minus m into, okay, myself forgot these formulas, but okay, it works. Next, for predicting, we have the self.m. Self.m is a slope. Okay, this will be stored in the form of a float, and then c will also be stored in the form of float. Now you can see how it is working here. It is our m, self.m, this is our m, xi, that is our x, plus self.c, that is our plus c, for xi in x. So it is doing it for every xi. How does it work? Our input can be 2, 4, 5. What will it do? First of all, we'll take the 2, then we'll be, suppose our m is here 3. Okay, and our c is like suppose 2. Okay, it will be like 2 into 3, 6, 6 plus 2, 8. Then this will be 4, 4 3s are 12, 12 plus 2, 14, then 5 15, 16, 17. Okay, this is our expected output. If we just try this, okay, let me just try this. Let's just remove this and let's put here or 5. 17 is expected, right? Yep, it works. So this is our linear model. If you want the code, just comment I need the linear model, or maybe just comment linear model. Then I will just upload it in my GitHub and reply you back with the code link. Now, should we understand this in graph form? Let's do it. I don't have any software for this. Let's just create a graph. Okay, that's it. This here is our y axis, this here is our x axis. Okay, now suppose we have the data. Yep, this one. I guess that will be too huge. Let's just start off with simple. Okay, if it is 3, it is 2. If it is 1, then it is 0. Yes, it does work with negative values. Let me just do minus 2, so it will be minus 3. Yep, yes, it works with negative values. Does it work with floats? Yes, it does work with floats. Okay, let's take this, copy. Let's head back to our paint. Here we go, paste it. Okay, so we got this data. Let me increase its size. Okay, now where is it? Too big. 26, yeah, that's fine. Okay, your x here is 1. So suppose let's take a pencil. Suppose this is 1, this is 2, this is 3, and this is our y0, y1, y2. Well, let's put some more, put some more, put some more. Okay, now it's if x is 1, then our y is 0. That is, this is our line. Then if x is 2, y is 1, then this is our line. Then if x is 3, then our y is 2, then this one. So from this, 3 is enough to tell us that it is in this form. So this is our graph for x equals to this. So what does the model do is, it finds its slope and then the intercept. Intercept was, I guess, this part, or maybe this part. remember quite well. And this is the gradient or the slope. Now, so if you want to predict for 1, 2, 3, 4, if we just put it up like this, we'll find, wait a minute, okay, so it must link with this. So if it is 4, it will be 3. Now it is not a proper graph, so it can be causing some problems here, but yeah, that's how the linear model works. It's just a simple line that's straight like that, and then based on that, after, suppose this is your n, and the thumb just, okay, using the touchpad for this was a bad idea. Suppose this is n, and then like that we'll just go up here, and then suppose if it finds it, there's your y that you need. This is the x value, and this is the y value that you need. So yeah, that's it. Thanks for watching. I hope you understood what a linear model is and how it works. You would surely need some maths for this. Yeah, understanding is not that hard. Understanding is easy, but implementing it is the hard part. This is the formula. You can take a screenshot or something, or maybe you can just write out this thing. Maybe post a video and then open your code editor and then write it, or maybe just comment linear model and I will provide a link. So that's it. And I have also made one here, linear stack model. What it does is pretty simple, a class and blah 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 blah. Yeah, I did not write all of this, it was written by ChatGPT. And well, this part too, okay, but yeah, this model was made by me, you can see, kind of. Yeah, it's easy to make. Linear stack model, what it does is stacks all of this single linear model together, like model 1, model 2, blah blah blah. If you want code for this too, just code linear stack model. I will upload it in my GitHub and provide you the link. So yeah, soon I will be trying to make a RNN. I know it's way too difficult for me to make. I'll try and provide a video. So till then, thanks for watching. Subscribe.